Okay, these are all minus signs. I don't know why this didn't come through. So what do we do when we want to get a common denominator, but they're binomials? So unfortunately, you can't just subtract 1 to the first, to the numerator and denominator, make them the same, right? If I have 2/3, is that the same thing if I take away 1, the same thing as 1/2? No, right? I can't just take away 1 from the numerator, take away 1 from the denominator, and assume that they're going to be the same thing to make a common denominator, right? So, to make a common denominator, in this case, our lowest common denominator would be the product of the two. Kind of like when you have something like 2/3 plus 1/2, the product of 2 times 3 becomes your LCD, or 6. So the product of the denominators is what's going to be our lowest common denominator. X minus 2 times x minus 3. Okay, so the first guy of x minus 3 over x minus 2, we have to multiply top and bottom by the other denominator of x minus 3 and x minus 3. Plus this guy of 2 over x minus 3. We're going to multiply top and bottom by x minus 2, the other denominator, in order to make them a common denominator. Okay, just like if I was trying to add these guys, I'd multiply top and bottom by 2 here and 3 here, the opposite denominators. Okay, so the denominator we can always leave factored. However, the numerator, because what we want when you actually add or subtract fractions, we keep the denominator the same, but we add the numerators, right? So in order to add those numerators, we're going to have to expand. We're going to have to FOIL. So we're going to leave denominator factored, but numerators we have to expand. Okay, so let's do that. How do I expand that? FOIL. X times x, x squared, and x times negative 3, negative 3x, negative 3 times x, negative 3x, and last, negative 3 times negative 3, plus 9. But the denominator we can leave factored. Okay, so plus, expanding this guy, distributive property, 2x minus 4. Okay, so now that our denominators are the same, can we just go ahead and collect like terms on the numerators and add? Okay, so once you have the denominators the same, 4 over 6 plus 3 over 6, when we add, yeah, we just add the numerators and put it over the same denominator, right? Keep the denominator the same. So same idea. We can go ahead, and if you want to write the extra step, I'll do it today. This numerator simplifies to minus 6x, right? X squared minus 6x plus 9 plus 2x minus 4 all over the common denominator. Just write it once. Or x squared minus 4x plus 5. Now, our last step is to check to see if the numerator factors. Does this numerator factor? Can we multiply to positive 5 and add to negative 4? Multiply to positive 5. How do we, 2 ways to multiply to positive 5. Positive times a positive, 1 and 5, or negative times a negative. And well, either of those add to a negative 4. No, so it does not factor. We check to see if it does. It doesn't. So we can leave it. And last, state NPVs. X can't be equal to 2 and 3. There's our answer. Okay. All right, this guy. It's already in factored form for us, which is nice. What's going to be my lowest common denominator? So we have to include everything, right? Once it's in factored form, we need to include, if it's already in both, you'll need one of them, right? So there's an x in both. That's going to be part of my lowest common denominator. What else? An x plus 5 and an x minus 1. Everybody has to be represented. Okay, so that's going to be our lowest common denominator. So basically what you're asking yourself is what's in the other denominator that this guy is missing, right? So what's missing from the first denominator that's in the other denominator? X minus 1. So let's multiply the numerator and the denominator by x minus 1. Get in the habit of just automatically putting these brackets there. Even if they're not there, it's safer. So this guy, I have 2x minus 3 all over x times x minus 1. What's in this, or the other denominator that's missing from this one? X plus 5. It's essentially how you figure out your LCD. I guess I can use a different color. So top and bottom, let's multiply by x plus 5. All right, so what do we do now? In order to add. FOIL. Okay, so this guy, x minus 1 times x minus 1. X squared. Then you're going to have a minus x and a minus x. So I'm going to go straight to simplifying that. Negative 2x. Is that okay? And then negative 1 times negative 1. That's 1. Okay, this guy, let's FOIL. 2x times 2x. Or sorry, 2x times x. 2x squared. I'm going to simplify the middle terms right now. So 2x times 5 and the minus 3 times x. So 2x times 5 is 10x. Minus 3x will be 10 minus 3, 7. Okay, so the two middle terms, right, are just those two. 2x times 5 and then negative 3 times x. So 10x minus 3x. And then last, the negative 3 times positive 5, negative 15. Okay, so can we start collecting and just add them now? Add the numerators. Yeah. And write it all over one common denominator. So, what does this add to? How many x squareds? 3x squareds? How many x's? 5. How many constants? Or 1. Minus 14. Does this factor? I'm going to tell you. No. We can check if you want. 3 and 1. And then our combinations are 7 and 2. So if I do this way, I get 6 and 7. So that can make 5. If I switch that to be 7 or 2 and 7, I get 21 and 2. That can't make 5. And then last is 14 and 1. 14 and 3. That won't work. And this would be too big. 1 and 14. So it's just not factorable. So we're done. Other than one more thing. NPVs. X can't be equal to 1 -5, and 0. Let's talk about all of this. Okay. All right. So notice that that one was already factored for you. The last two, well, the first one didn't need to be factored. The second one was already factored for you. The third one, guess what we have to do? Factor. Yay, factor the denominator. So let's factor the denominator, because you can't factor the numerator. What does that factor to? Two numbers that multiply to 6 and add to 5. 3 and 2. Two numbers that multiply to -12 and add to -1. 4 and 3, who's negative? 4 is negative. Good. Okay, so what's missing from the second denominator, or sorry, the first denominator that's in the second? What does this guy over here have that this one doesn't? The y minus 4, right? So he's missing the y minus 4. We're going to multiply top and bottom by y minus 4. Okay, so this guy, y minus 4 and y plus 3. What is missing from that denominator that's in the other one? The y plus 2. So top and bottom, you have to multiply by y plus 2. Now subtraction we always have to be really careful with. Okay, so we want to simplify everything before we start to bring them together and subtract. So let's start by simplifying our numerators. So what is the numerator here simplified to? 4y minus 16. Okay. Subtract. This guy will become 7y plus 14. Okay. Here's the thing. There's a few ways you can approach this subtraction. Okay? The first way is you can turn it into addition, right? How can I change this into addition instead? Switch all the signs. So I can change that to addition by making this instead of -7y and a -14. That's probably your safest bet. The other way is you would have to, if I'm writing this out, put brackets here when I put it all over one denominator. Oh, this is a plus. Okay, so you're still going to have to switch those signs. So to be safe, it's always safer to make it addition by switching your signs. Now we can go just add. So all over one denominator because it's the same. This becomes 4y plus -7y. -3y. -16 plus -14. -30. Now, can we factor that numerator? Yes. Will it do us any good? So what can I factor out of this numerator? A -3, and we'd be left with y plus 10. So we do want to see if factorable. We do factor just in case something cancels in the end. And we can reduce further. But does it do us any good? No, it doesn't make a difference. Nothing cancels out. So that's why I wrote or here. Either or would be an acceptable answer in this case because nothing will actually cancel out if we factor it. I'm just missing one more thing. Why can't be? -3, -2, and 4. Okay. So we always check to see if things simplify at the end. Often they don't, but we always check. Okay, this is one of my favorite examples. You could start this question. Our first step when we're adding and subtracting is to do what? Factor. Okay, so step 1, factor. Now, there's something that hasn't happened yet, but you do want to check for. Before finding your common denominator, check for simplification. Because sometimes you can actually simplify before you add and subtract. If you're getting problems where you're expanding and you're getting to the power of 4s or power of 3s, chances are you forgot to simplify further in the beginning, and I'll show you in a second. So check for simplification and then find out LCD. Okay? Then we're going to find that lowest common denominator, add or subtract the numerators, life is good. And then last is check for simplification at the end. Okay? But this step here, we haven't really come across yet. Before finding the LCD, if everything's factored, is there anything that can simplify? So let's look at this guy. Factoring the numerator, what does that factor to? Two numbers multiplied 12, add to 7. X plus 4, x plus 3. So I'm going to factor to check for simplification. Two numbers that multiply to -8, add to +2. So there's 2 and 4. -2, +4. Okay. Minus. Two numbers that multiply to a -2 but add to a +1. It's 2 and 1. If you want to add to +1, -1 plus 2. And then what can you do with that denominator? To factor out the 3, x plus 2. Okay, so we haven't found lowest common denominator. Are there things that can be simplified in each individual? We can't cross simplify like we can with multiplication and division, but in this fraction here, is there anything that can be simplified? Yeah, the x plus 4s, and then the x plus 2s. Do you see how now this is becoming a much easier thing to add together? Or I guess subtract in this case. That's a lot simpler. Significantly. See, if you didn't do that, if you didn't simplify like that, and this is what happens on quizzes often, is students then would be like, okay, what's missing? I'm missing a 3. I'm going to multiply top and bottom by 3. And then I'm missing an x plus 2 here. So up top and bottom by x plus 2. This numerator is going to become a cubic. Because when you FOIL this all out and write all 3 of them, it becomes a cubic. Same here. This guy is missing, okay, this guy's missing an x minus 2. That guy has that, an x plus 4. This is going to be a quartic. Okay, if you're getting cubics or quartics, something should have simplified earlier. Okay, too big. Do you see what I'm saying? Here, like if I didn't see the p's cancel, and I'm trying to include all of that in the denominator, it's just going to get ugly. Really ugly, really fast. That's happening. You should have simplified earlier. Okay? Alright. So, now, what's missing from this first denominator that's in the second? 3. So top, multiply the numerator by 3 and the denominator by What's missing from this denominator that was in the other one? X minus 2. So we want to be careful with subtraction. So this guy, let's expand them first. 3x plus 9 all over. Always leave your denominator factored. Always, always, always. Okay? Denominators always leave factored. Subtract. Let's FOIL this out. X squared. So my middle term is going to be the outside and the insides here. So negative 2x minus 1x, negative 3x, and then last, negative 1 and negative 2, plus 2. Okay, if you're subtracting, what should we do? Switch signs. So we're going to make this addition instead. And all of these signs switch. So instead we have a negative x squared, a plus 3x, and a minus 2. So now we can collect terms, put it all over one denominator. So negative x squared, how many x's? 6, good. 3x plus 3x. And then how many, plus 7, thank you. Okay, this guy's kind of weird because there's a negative x squared. So if you ever have a negative x squared and you want to see if it's factorable, what you need to do is GCF the negative out. Okay, take the negative out of this whole thing and then see if it's factorable. Because we always want our x squared positive. Is that factorable? Are there two numbers that can multiply to negative 7 but add to negative 6? Negative 7 and 1. Okay, so if I did that, x minus 7, x plus 1, does it do us any good? Did it help us out? Did anything cancel in the end? Sometimes things will. Like in our examples, they haven't, but sometimes they will. So either or is an acceptable answer. I'll accept. Only because nothing will actually cancel. But we do have to check still. One more thing. X can't be 2. All right. One more quick example. It's a little bit of an extension. It has to do with more so of dividing and multiplying, or dividing, more so than adding and subtracting. And then we're done the lesson, which is good. Lots of time for practice because you need it. So here's the thing. We have two methods when you have a fraction divided by a fraction. Okay, it looks pretty ugly, right? So if you have a fraction divided by a fraction, your first method is to get a common denominator separately. So what I mean is, okay, let's look at this numerator here. What would be the common denominator there? 2, because x right now is over what? Is over 1, right? You could write that instead as half plus x over 1, right? All divided by, this guy would be a third minus x over, well, right now, you could also write that as x over 1, okay? So we're going to separately get common denominators. So what I mean by that is this first guy, this numerator, we're going to get a common denominator of 2. So it becomes a half, that's not what I want, a half plus, what does that become? 2x over 2. We multiply top and bottom by 2. Okay. All over this guy, what's that guy going to become? Here, common denominator will be 3. So it becomes 1 over 3 plus, oh yeah, it's a minus, thank you, minus 3x over 3. Okay. So we do that so that we can now add those numerators. We can add 1 plus 2x and put it all over 2, divided by 1 minus 3x all over 3. And we've seen examples like this before, where we can just rewrite this so it's not as scary, right? Now we can write this as 1 plus 2x over 2 divided by, see, that's not so scary, 1 minus 3x all over 3. You with me still? Okay, so what do you do when you divide? Yeah, okay, you guys got it. All these good words. So we multiply by the reciprocal, 3 over 1 minus 3x. And so this would just become 3 times 1 plus 2x all over 2 times 1 minus 3x. Or, if you want, you can also write it as 3 plus 6x over 2 minus 6x. Okay? Either or. Okay, that's the long way. There's an easier way. A shortcut. I'll show you really quickly. So that's method 1. Ugly. Very ugly. Okay? So method 2, or the trick, says up above here, it says multiply by common denominator, get rid of the fractions. So that doesn't really make sense. Let me explain again. So we look at the two denominators inside the numerator and denominator. I'm looking at 2 and 3, and I ask myself, what would be the lowest common denominator for 2 and 3? 6. So what we're going to do is we're going to multiply the numerator by 6, and we're going to multiply the denominator by 6, because what I do to the top, I'm going to do to the bottom. And what this is going to do is eliminate that fraction. Because, what's 6 times a half? 3. What's 6 times x? 6x. Okay, what's 6 times a third? 2. And 6 times negative x? Negative 6x. Easier? Much easier. It's quicker, it's easier. So what would we multiply top it? So we look at these denominators here. Which ones am I looking at specifically? The x and the 3x, okay? What would be the LCD for x and 3x? Okay, 3 and, you're also missing one more thing. X, 3x, would be 3x, okay? So we'll multiply top and bottom by 3x. Like that. Okay, tell me, what is 3x multiplied by 1 over x? Yeah. So notice this is 3 over 1, right? And so what happens with the x's? They cancel. So this is just 3 plus, and now 3x times 3 is 9x. Okay. Now, what's 3x times 2 over 3x? This is 3x over 1. What's that equal to? What cancels? The x's, what else? Do the 3's cancel? 1 on the numerator, 1 on the denominator. So we're just left with 2. 2 plus 3x times 2, 6x. Now you're done. Okay. All right, so, okay, no, that's the wrong one. Assignments on the front, so you hopefully have already done Friday's homework. Friday's so you want to make sure you've done Friday's before you try today's because it kind of warms you up. Today's Monday. Page 336 to 340 as well. Numbers 6A to D. 6EF are optional. So it's up to you if you want to give those a shot. 7 to 9. 10 is optional again. If you want to try them. 15 is optional. So mandatory would be these guys. Okay? So you want to make sure you practice that adding and subtracting. There's going to be a lot of written on this quiz. Okay? ID? Started.